live session is called How AI Agents Are Transforming Hull Performance Analysis. So, my name is Anne-Sophie Fischer, and I'm very happy to be hosting today's discussion where we will explore how AI powered agents inside SmartShip are changing the way maritime teams analyze vessel performance. So, across the shipping industry, operators are collecting more data than ever before from vessel sensors, noon reports, weather information, AIS data, and operational history. So the challenge is not collecting data anymore. The real challenge here is turning that data into clear operational decisions. And traditionally, as you all may know, performance managers and analysts spend hours, sometimes even days, analyzing vessel performance data to understand issues such as fuel inefficiencies, hull fouling, or performance degradation. This is exactly where the hull performance AI agent comes in. So, inside SmartShip, this AI agent acts like a digital vessel performance analyst. It continuously monitors vessel data, it validates the quality of the inputs, analyzes the trends in performance, and provides clear recommendations for operational decisions, such as when hull cleaning may be required. So instead of spending time analyzing data manually, teams will receive clear insights, estimated fuel savings, and recommended actions in a few seconds. So today I'm joined by Ride, who has been closely involved in developing actually the AI capabilities within SmartShip. And together we will explore what the whole performance AI agent actually does. Second, how it analyzes vessel performance data. And also, third, how it helps operators make faster and more confident decisions. So, without further ado, Ride, could you maybe briefly introduce yourself to the people who are here live and your role within SmartShip?
Sure, Sophie. I'm a solution expert, primarily focused on smart ship solutions, which is focused on the vessel performance and asset management perspective. And my primary role relates to helping out clients to identify the right fit of the solutions to identify the ROIs as fast as they can.
Super. Thank you. So I think today what we wanted to do for everyone was to actually start with a bit of a demo, a little demonstration of the tool. So Ride, could you maybe walk us through an example inside SmartShip and show us how the Hull Performance AI agent actually generates an AI insight in practice?
Sure. I'll just share my screen.
Yep.
We'll quickly show you how it looks. So here is what a smart ship screen on a specific hull performance would look like. Here we are looking for a vessel performance for a vessel called Global Voyager. The primary KPI or the metrics which we are trying to monitor is excess power percentage against sea trial conditions. And this is a 1 year data. So that means this specific vessel had gone for a dry dock in 2024. And then from there on, we are regularly getting the data, shaft power, the high frequency data. And then we have started plotting it out. The, the ship has also done a hull inspection. That means they have also looked into the performance or the condition of the hull. So we also have a report based on that. Now you can see that there is a lot of data which has been gathered, and there is a decent understanding of what kind of deterioration the hull is facing, right? And over that, a vessel performance manager would be going through a lot of change of the sensor data points to just analyze it little better to ensure that the data quality is good, right? Uh, we have all the options of choosing a lot of data points, be it SOG or hindcast STW or a log STW, weather conditions from hindcast data source or an anemometer. So the biggest problem with a vessel performance manager was to keep changing on these settings and then identify which is the right fit. That's the first level of the problem side. So what the team has done is that they have created an AI insight on that. All that they do is they just click on that. Or what this engine is doing is it's first pulling out all the information about the vessel, right? The smart ship has all the initial information, the sea trials, uh, hydrostatic data, so it understands like what kind of model it has. Then obviously the hull event informations. Then it will look into the sensor data, and then it gives you a summary of what exactly it feels. So a logical way of understanding all the data which is possible. Look at this. Now for this analysis, the engine has found that it is moderate to poor condition. It is seeing a deterioration per month in the excess power. It is also identifying that in the last inspection, what was shared in the inspection report for the bifouling, there is a proper financial ROI case which has been built based on saying that if you would go for such a cost savings, then you would achieve a $34,000 worth of cost saving. That would give you a clear indication whether you should be taking an action or whether you should wait for certain action. And then there is a confidence score which further helps you to understand that how confident is the system on that. This gives you the transparency or the understanding of what kind of and engine it works. How is it looking for? Is the model good enough for the analysis, or is the data is like absolutely not useful? Then to make it easier for the vessel performance analyst, it also provides a lot of data points, be it LRMs, the speed loss, the excess power, excess consumption. These kind of matrices further validates their logic. And then in the end, you can see that there is a lot of confidence scores, a lot of information which needs to be gathered. Consider a vessel performance manager would be looking for so much data point just to make a context out of it. All that is now arranged in one single place. So this provides a complete analysis for anyone. And think of it as easy as every day you can come in and just click on it, and it will develop its own summary for the whole data points what it has. So that's the HPM agent which we are talking about. That we believe that it will ease the life of a vessel performance manager.
Super. Thank you, Rede. I think it's very clear, and I actually really like that it gives a confidence score as well. It makes you understand also that this is something that was done, and it doesn't mean that you should take it for face value, but more so take it to make then yourself the best decision possible. Okay, I think we have a few questions that, of course, as we go, maybe also our viewers may ask more questions, but one question that I think a lot of people may have and I think would be interesting to tackle is we call this hull performance AI agent, we describe it a bit as a digital a vessel performance analyst. So maybe can you help for the viewers to explain what that means in practice and what the agent actually does inside SmartShip?
Sure. So uh, this agent is more than just a dashboard, right? I mean, the team wanted to create a tireless 24/7 expert, an analyst, dedicated to your fleet efficiency. That's the major idea with which the product team worked on this. So it bridges the gap between a sensor data, raw data which is coming out, and then to the commercial action. Uh, it is trying to ensure that when you're spending a maintenance cost of hull cleaning or propeller polishing, it makes sense. It just gives you an ROI. In a traditional setup, a human analyst or a vessel performance analyst would be spending around about 80% of their time just to ensure that the data is good, or just to ensure that at a certain point datas are not missing out now. And they would only spend 20% of the time to actually set up a context and understand and do an analysis on that.
Hmm.
This is where the agent is flipping the script. It is taking the major burden and acting as an expert, basically looking into as an analyst, and then replicating the discipline and the contextualization of the data available. uh, the primary job which the agent we believe is doing for the vessel performance manager or an operator or a technical superintendent would be that first it will understand the data guardrails which needs to be there to ensure that you're not being disturbed with off sensors, invalid data. Then there has to be a contextual intelligence. That means to you look back into the data, whatever you have, whether the hull cleaning reports or when was the hull inspection done or when the dry dock was done, and try to make a context out of it. And then you also have a reference benchmarking on that, saying that be it just the sea trial or the best performance after the dry dock conditions which you want to reference to. And after that, try to build up a financial impact mapping, saying what would help you, what kind of an ROI you should have if you would clean on this. So trying to make a full circle out of it, trying to give you a report which then a vessel performance manager and an operator can look into and take a proper decision on.
Hmm. Yeah, no, makes a lot of sense. I also wanted to tackle a point. So, we talk about hull performance, right? And obviously, hull performance has a major impact on fuel consumption and operational costs. But I think maybe what could be useful for our viewers would be to explain a little bit why we think monitoring hull performance is actually so important for operators and ship owners, and how this AI agent actually helps identify issues like hull fouling.
Yeah, sure. So we all know, I mean, hull performance is the single largest variable in a vessel's daily OPEX cost, right? I mean, and remember, I mean, it is the one of the most, it's a silent thief on your efficiency. I mean, you
Mm,
get the data, typically, you will get the data so late that you would have already lost a lot of fuel just because of your inefficiencies. And that is where you can actually make your vessels really efficient. Now consider it that if you are getting high frequency data and then you are doing a regular analysis, this is
mm,
going to be a game changer. Now you are having a 24 bar 7 analysis every day. A lot of data is coming in and it is being used to identify what is your hull fouling conditions. Think of it as an actionable commercial ROI given to you straight as a report. By shifting this reactive to actively monitoring of the hull performance, this agent provides three critical business levers for you, right? So first is obviously a financial precision on identifying whether it makes some case for you or not. Typically you would be spending about 10K to $20,000 trying for your hull cleaning, propeller polishing, and you need to understand, or you need to have a good context before you take that decision of saying that what would be your payback period. Maybe you are going for a ballast voyage, maybe that doesn't make sense. Maybe you are going to for going to be an idle condition, maybe you have an anchorage, right? So you need to have that kind of an ROI case built up so that you can think about whether you should be going for cleaning or not. So that
mm.
is a primary one, but there is other parts to it. Think of as an owner, right? I would need an operational security saying that whether my engines are being overloaded or not. That means I want to look into the light running margins, right?
Yeah.
This protects you, saying that if your light running margin is inefficient, that means there is chances that you are running it inefficiently or putting a higher load on the system. So that also takes care of your asset, right? And the third part, which is most important for the system to work together between a charterer and an owner, is primarily to understand how to provide the right data to say that why a hull is behaving in a certain way, or why a hull is consuming more fuel. So to provide that defensible data saying that we can attribute a poor performance to hull fouling, that is where the key part is. That means there should not be any uncertainty when such an analysis is provided. Both the parties agree on that and then quickly get
Mm.
into the action mode. Essentially, we are moving the conversation from guessing the hull conditions to managing it in the same rigor you would apply to a financial portfolio.
Yeah, super clear. Yeah, it's what you said about, this shift from reactive maintenance, right, to more active, more managing, more control. So yeah, super, super clear. Thank you for sharing that, Ride. And something that I also mentioned in the beginning is that actually today the challenge is not about collecting data, right? We're able to collect data. And I think maritime data can often be inconsistent or unreliable. And this is something we also hear a lot, right, through our clients. And so I think here an interesting maybe question for you would be to explain to our viewers, how does the Hull Performance Agent, AI agent, should I say, validate and select the most reliable data sources when analyzing vessel performance?
Yeah. So like any vessel performance manager or a owner or a charter, right? I mean, we all know that the primary risk just does not lie with, a bad data. The primary risk is that if you have taken a bad decision based on the data which is poor. So that's the risk with which we all live in, and that is where we wanted to be very sure of that the agent absolutely works properly on that, right? So we wanted to create a single version of truth so that both the parties, anyone who is looking into it, does accept that thought process and say that yes, it's a properly rigored checked data which is there to being used for your analysis. So
Mm.
uh, rather than taking, so our thought process is very simple. Obviously any vessel performance manager would obviously say that we cannot take the raw sensors data on the face value. We have a lot of regulations, a lot of provided guardrails which everyone uses in the industry. So we also use that, but we also trying to make it more comprehensive in nature, to identify the validations, interpretations on that. So what we are trying to do is we are trying to put a gate and modifier logic saying that if I'm looking into speed, let's say the log speeds, we know that there is a chance of a drift, right? So can we dynamically keep monitoring on the speeds? Can we ensure that there is not too much of a drift? Is there a chance of the speed sensors going off and giving you a wrong analysis? Now that can be done if you can cross validate with 2 3 of your data points, right? You should not stop with one cross validation. You should cross validate with 2 3 data points. Let me give you another example of torque sensors, right? So shaft power is there. You are trying to understand using the shaft power how much excess power you're consuming, but you should also check whether it has been calibrated or not. You should also check that whether it relates to the same thought process as a flow meter is doing that or not. Or you should also think about it, if I have a scavenger pressure of the main engine, does it closely relate to that, right? So you need to cross validate a lot of places to ensure that the data is quite good for your analysis. And obviously in the end there will be normalizations which we'll do for the good weather data, or typical guardrails for the drafts and for the current which you will put. That is obviously taken in. So primarily the process which the agent is looking into and trying to simplify by looking into data is that this maritime big data which we have, or which we have now, can it be converted into a maritime smart data, reliable data, to take a defensible action on saying that why you should be going for a cleaning, or what is the current condition of the hull.
Super, super. Thank you. That makes a lot of sense. And I think also something that we talk about with our customers, and we also mentioned earlier today, it's that one of the key benefits of this AI agent is that it can reduce, I mean, days of manual analysis into basically seconds, right? As we saw from your demo. So, can you maybe walk us through how the agent actually automates this process for performance managers, and maybe, what does this mean in terms of some strategic advantages that we can think about as from a business perspective?
Sure. So first of all, like, this is an automation, right? I mean, so you're doing three-step process. What a typical analyst or any operator or any user would do is first to ensure that the data is clean, then to
Mm.
ensure that it is normalized properly, and then go for your analysis, right? If we can do these three processes properly and diligently, then pretty much we have created a standard so that the vessel performance manager now can come in, agree on the context, agree on the summary, and take a proper decision, right? I'm not betting on saying that the analysis will be absolutely foolproof, because there will be still a lot of context which the system may not have. That is like your operational knowledge, how, what is the a different kind of paint which you have applied, maybe a conversation with the paint maker, which is something where the vessel performance manager should come. So that is
Yeah.
where we are focusing on now. We want the vessel performance managers to stop questioning the data. It's enough
Mm.
now to keep questioning the data and saying that whether it's good enough, and you should start managing the fleet.
Mm.
From a business perspective, think about uh, eliminating the human bias and the noise. Typically sensors do bring the noise, and there will be always a bias. For you it may be a bad hull condition, or for me it's maybe a start of the deterioration, right? I mean,
Yeah.
we can interpret it in different ways. We all know that there is different graphs and you analyze it in different ways, but that is where we are trying to step in and say that there has to be one standard way to look things. So that is what we are trying to do. Second, obviously we are focusing on benchmarking, right? So typically in industry what we are trying to do is we are saying that against a sea trial condition, what is your excess power, or after the dry dock we have seen your performance, and then from there how much you are deteriorating. Now that's like dynamic or a static benchmarking, right? What we are trying to do is that we are trying to gather all these information and try to make a sense of it. So not just saying that against a sea trial condition how off you are as an excess power, but we are also trying to say that from your best performance available, which may not be obviously a sea trial condition, which may be little bad than a sea trial condition, from there how bad you have deteriorated. So I'm also trying to understand that how your performance is degrading over the time. And then it's paramount, which is the most difficult part for any vessel performance manager, is to make a business case out of it, right? So right now it is considered as a maintenance cost. We want to convert that conversation to saying that it's an investment.
Mm.
You have an ROI and you have an investment. It's an investment decision. If you have taken something, and if your ROI is getting you before a month the complete the cost, then I think it's a solid bet to get in. That is where we are trying to have a conversation there. And ultimately this is moving the data for our customers from a data gathering, data basic analysis, to proper management, protecting your margins from the high cost of the analytical delays.
Super. Thank you. I think we can tackle maybe one question that I'm seeing in the chat if you want. So, we have one viewer who said there were a lot of data on this dashboard. Over this last 1 year, how many data points did we collect roughly to be able to get the kind of insights that we have today?
Sure. So, why you had a lot of data points? That's a very good question here. This was because we were using high frequency data. That means every data point was representing a good weather data point for an hour, right? So we have our own ways. In this current system we are acquiring a data every 30 seconds. So that's why you have a lot of scatter to understand. uh, but consider if we have good 50 data points, 50 data scatters, that would be a good start to understand what is your hull conditions. We don't want to be too quick to say that suddenly everything is hunky dory. So this agent will create its own validation saying that whether it's sensible or not. Say during those 50 data points I figured out maybe your shaft power is too off against your flow meters. That means I'm not sure now whether your shaft power is good or your flow meter is good. So I would for sure as an agent would ask you to calibrate it out and increase the time of the analysis, right? So the agent will keep highlighting this to you saying that I cannot do it or my confidence score is less. That is why I need more data to do the analysis, right? So it's not a direct answer saying 50 data points will make an answer. Obviously it should have a decent 50 good data points to start the analysis. But our recommendation would be that's why go through the agent, try to build up your confidence, and then take an action.
Super. Thank you. I hope we hope this answers your question. We have one more question, which basically you can tie into this one. But what kind of high frequency data is collected? So is it speed, consumption, idle stays? Where is the data stored?
So SmartShip is a solution now. It's agnostic to how you get the data, right? So We have in Zero North our own acquisition system. We have set it up for 30 seconds. That's what we like to operate on. But absolutely, I mean, you can get us your cloud data through an API, and you can get me till 10 minutes of frequency data, and still we can manage with that. Uh, if we are talking about the data sensors, obviously typical data sensors which we would need for such an analysis would be shaft power, flow meter, maybe one of them, preferably shaft power, that's more reliable. uh, Obviously the speed sensors, AIS data, uh, anemometer data if it is possible. uh, then draft sensors if possible. Otherwise we have a method to get your draft data from your noon reports, or you can manually input that, or displacement data. And then if possible, that's where we start going little better and say that if I can have your heading, if I can have your rudder conditions. Primarily now I'm trying to figure out whether there is an acceleration, deacceleration, conditions which should not be considered. So absolutely there are some specific data points, but I've tried to give you the main data points which I would need for an analysis.
Super. Thank you. And then another question is about how fast are you able to determine the current hull condition after departing from a long idle stay? So 1, 2, 5 days or more for noon report setups, not high frequency.
Okay, so for a noon report setup, it's little different, right? So I mean, you are having everyday data. Uh, Primarily, it also depends. Again, as an analysis, it depends how confident you want to be in. Be it, are you okay with taking a before weather of 5, or are you okay with before 4? But ideally, my recommendation would be still wait for at least 30-35 days of work, right? So sailing period, that would give you a decent, because before that you are primarily trying to guess things out, trying to say that what kind of consumptions you are having, right? Yes, there are absolutely conditions where you have done a long idle stay, pretty much you have started in and then you cannot reach the maximum power. But I'm not considering those situations, I'm just considering a basic situation. My recommendation here again would be a 30-35 days sailing. But that is where you should be starting building confidence on that.
Super. And maybe one last question that we have. How is the agent actually going to tackle sensor issues like SPM giving abrupt readings? How is the agent going to tackle incorrect data input from rough sea situation, hampering main engine power data?
Yeah, so absolutely. So that's what we said. I mean, if there is a rough sea data, right? So I am already looking into the hindcast weather data and not taking into consideration. So when I showed you that scatter, it's primarily looking for stable state conditions in good weather. That's the first thing. Now the spikes on your shaft out meters, or sensor drifts, this is where the agent becomes really powerful, right? The biggest cases of saying that your flow meter is going off or your shaft meter is drifting, you need to calibrate. The agent figures out. Again, remember, when you're doing an analysis over a 6-month period or a 3-month period, there could be chances that sometimes your shaft off meter is working well, sometimes your speed sensor is working well, and you're doing the maintenance off and on, right? That is where the agent becomes powerful, because it is using the right set of data at the right set of time to do this kind of analysis. It's not saying that all the time your shaft power will be good. So what it is doing is it is cross validating itself against a flow meter. If I have a scavenger pressure, I will cross validate against that. And then obviously an RPM. So I'm trying to cross validate against typically 2 3 parameters to ensure that if my shaft power is not off by too much, then only I'll consider it in my analysis.
Super. Thank you. I think that's it with the questions, and I know we have basically run out of time. So I just wanted to thank you, Riday, for walking us through the Hull Performance AI agent works inside SmartShip, and thank you to everyone who joined us today. Obviously, the Hull Performance AI agent is just the beginning of how AI can support smarter vessel operations and improved fuel efficiency and overall better performance management across fleets. So, if you'd like to learn more about SmartShip or see how the Hull Performance AI agent works in practice, please feel free to reach out or visit our website. And thanks again for joining us. We look forward to continuing the conversation. Thank
Thank
you.
you.